to our algorithm YouTube channel. Today we are going to solve Leetcode daily challenge problem. The name of the problem is max area of Iceland. Let's read the problem statement first. You are given a m cross n binary matrix grid, and Iceland is a group of ones representing land connected four directionally, horizontal or vertical. You may assume all the four edges of the grid are surrounded by water. The area of an Iceland is the number of cells with a value 1 in the Iceland, and we will have to return the maximum area of an Iceland in grid. If there is no Iceland, we will return 0. So let's firstly discuss about the DFS approach. Then we will see DSU approach, which is known as disjoint set union. Here, this like I have taken this as a sample test case. As you can see, in this particular test case, this one is connected with this one, and this one is further connected with this one, and this one is all further connected with this one. So here the answer output should must be 4. Okay. Now the intuition that comes into my mind is, can we apply DFS, like picking a particular cell and going in all the four directions? Can we apply this? So let's move to the algorithm part. So here's my algorithm. We will firstly create a visited 2D vector of the same size as the given grid vector. This visited 2D vector keeps the track of the visited cells in the grid. We will initialize a variable answer as 0. It will keep the track of the maximum area of islands that can be formed so far. Okay. And we will traverse all the cells one by one, starting from the cell which is 0, 0. And if the current cell is not visited and value at grid is equal to 0, then we will pick up this cell as the starting point, and we will start traversing recursively in all the four adjacent directions. Okay. We will initialize a variable. Let's call it current Iceland area as 0. This variable keeps the track of the area of current Iceland, and at each recursive call we will check whether the current cell is already visited, uh, and like we will also check whether I and j my I and j index are going to, like, going out of bound of the matrix, and whether the value at the grid is 0. If any of these three conditions is satisfied, then we will simply stop the further recursion. Okay, and we will return out from the function. If this is not the case, we will mark the current cell as visited in the visited vector. We will increment the value of current Iceland area by 1, and recursively we will call in the four adjacent directions. Okay. At the last, we will have to update our answer variable as the maximum of answer and current Iceland area. Okay. So let's move to the implementation part. As you can see, here n denotes the the number of rows that are present in this grid metric 2D vector. M represents the number of columns in the grid 2D vector. Here visited, like I have initialized a visited 2D vector whose number of rows is same as the grid, and columns are also same. I have initialized this 2D vector as false initially, because initially we are assuming that none of the cell has been has been traversed yet. Okay. And I have initialized answer variable as 0 initially. This will keep the it will keep the track of the answer so far, like the answer formed so far. Okay. Now we will start traversing starting from the cell 0, 0. If the current cell, like let's say I comma j cell is not visited and the value present at that particular grid is equal to 1, so like we will start traversing, like we will firstly initialize a variable current Iceland area as 0. Okay. And we will call helper function by passing the I comma j grid visited n comma m current Iceland area. Okay, so let's move to this helper function. This is our helper function. So the first thing that we will do is we will check whether it is going out of bound, whether the indices are going out of bound or not. So we will check I is greater than equal to n, or j is greater than equal to 1, or I is less than equal to 0, less than equal to 0, sorry, or j is less than 0, or whether this cell has been visited, has been already visited or not. We will also check this one, or if the value stored at the grid is 0. If any of these condition is satisfied, so we will simply return out of this function and stop the further recursive calls. Okay, and if this is not the case, we will mark my current cell, which is I comma j, as true, and we will increment current Iceland area by 1. Okay, and we will start traversing in all the 4 directions. Okay, and as you can see, I have passed current Iceland area as a reference because I want to calculate the number of ones that are present. At the end, my current Iceland area will keep the track of the Iceland formed, current Iceland formed. Okay, and I will update my answer variable as the maximum of current Iceland area and answer. Okay, and at the end we will return the answer. So this is all about the DFS approach. If I talk about the space and time complexity, the time complexity, here the time complexity is big of n cross m, and the space complexity is also the same, where n represents the number of rows in the grid and m represents the number of columns in the given 2D vector grid. Okay, why this is so? Because let's take this example. Okay, because suppose we are traversing this one. So when I will start traversing this cell, so this is also traverse, this is also traverse, this is also traverse, right? And when I will start traversing this particular row, the third row, so suppose I am at the second column, this one, so I will check now whether this is visited or not, because I am as you can see, we are keeping the track of the visited cells with the help of this visited 2D vector. So we will not we will not start traversing again. Okay, we will simply skip it because we have imposed the condition here, if visited ij is not true. Okay, so like at most we are going to traverse, let's say let's talk about the worst and best case. Okay, the worst case is going to be this one. Why? Suppose I will start, let's start traversing from this particular cell which is 0 comma 0. I will start traversing in all the directions, so these all cells would be visited in the when I will reach I comma 0 comma 0. Okay, now further we will start traversing because I am I am traversing with the help of nested loops. Okay, so this will be checked again, this will be checked again, this will be checked again, and similarly all the cells will be checked again. Okay, so at most we are going here how many times we are going here, n cross m. This is the first time when we'll reach 0 comma 0, so these many cells would be traversed. Okay, and after that we will traverse n cross m minus 1 cells. Okay, so it will be nothing but we can say that 2 cross m minus 1, right? So if I take the big O notation, if I talk about the worst case complexity, which is big O notation, so it will be nothing but n cross m, because we in big O notation we ignore constant terms and the coefficient. Okay, so it will be big O of n cross m. This is the worst case. And in the best case, we have all zeros. Here the output would be 0. Okay. But in this case, all the cells would be traversed only once. So here the time complexity would be strictly n cross m. Okay. And why the space complexity is big O of n cross m? Because we are creating a 2D vector visited of size n cross m. Okay. So that's all about DFS approach. So let's quickly discuss about the DSU approach, which is known as disjoint set unionum. So let's this time take this as a sample test case. Okay, as you can see here, the answer is 7. Like I have marked the Iceland with green color. Here's the algorithm written down. So we will assume each cell is marked with unique ID from 0 to n cross m minus 1 inclusive. Okay, so here we are trying to assign a ID to each of the cells, and the IDs are going to be unique. Like no two cells can have the same ID. Okay, for example, suppose I comma j, for the I comma j cell, its ID can be calculated as I cross m plus j. Okay, we will create a leader vector. The name of the vector is leader of size n cross m, and we will initialize it with -1. We will also create a vector by the name rank, and we will initialize it with 1. Okay, we will initialize an answer variable as 0. It keeps track of the maximum area of Iceland that can be formed so far. Now we will start traversing all the cells one by one. We will check whether the current cell has a value equal to 1. If this is the case, we will check whether the cell at the position, the upper cell, okay, like I minus 1 comma j has a value equal to 1. If this is the case, so we will union both the cells with the help of their IDs. Okay, also we will if the cell, the left cell, okay, which one, I comma j minus 1, if its value is also equal to 1, so we will again union the current cell I comma j with the cell I comma j minus 1 with the help of their IDs. And ID, as I already told you, can be calculated as suppose I comma j is the cell, so we can easily calculate it with the help of this formula I cross m plus j. So let's discuss what we are trying to achieve in the union function. In the union function, we will unite both cell IDs if their leader is already not the same. If their leader is not the same, we will union both and return the rank of the leader formed after union. Okay. Also, after this union operation, we will update the answer variable as maximum of answer and the result of union. So let's discuss about the implementation. Here n denotes the number of rows present in the 2D vector grid. M denotes the number of columns present in the grid vector. As I told you, leader will keep the track of the leader of all the members. Initially, like all the members are independent of each other. That's why I have initialized it with -1. It basically means that each member is the leader of itself. And then I have initialized rank. I have declared a rank vector and it is initialized with 0. Now rank denotes the number of number of members that have the same leader. Okay, number of members that have the same leader. So initially, each, as I already told you, each member is the leader of itself. So I will initialize if like the grid value is equal to 1. So I will mark the rank of that particular member as 1. Okay. And we are using we are not use since we are given only I comma j, so we are getting the id, as I already told you, can be easily found with the help of this formula I cross m plus j. So with the help of this we are getting the id and we are marking the rank as 1. Okay. And this is our edge case. I will come to this edge case later, why I'm writing this. Now I will start traversing grid 2D vector. If the value stored at the like here, if the value stored at I comma j cell is equal to 1, I will check whether the upper cell is valid or not. And if it is valid, so whether the value stored at this particular grid is equal to 1. If these both conditions are satisfied, I will simply call union members function. So let's move to this union members function. So this is my union members function. In this function, I am firstly finding the leader of member 1. Okay. Here, like as you can see, the member 1 is nothing but the upper cell. Okay. And I am converting that cell into its ID. Okay. This is the ID of upper cell. And the second argument is the ID of the current cell. And I am passing rank vector and leader vector. Okay. So let's move to the union members function again. Here I am getting the leader of member 1 with the help of find leader function. And in the second statement, I am getting the leader of member 2 with the help of find leader function again. In the find leader function, we are getting the what is the who is the leader of member. Okay. So it finds me the leader, or it finds me the leader of this particular member. Okay. So if the leader of both the if the leader of both the members is not the same, or we can say if it is different, then we can unite them. Okay. So this is similar to like suppose we have two parties. Okay. And several members. Let's denote the members with green color. Okay. And let's denote the leader with pink color. Now here what we are doing, we are finding, suppose we have to unite these both these two members. So we are firstly checking whether their leader is same or not, and then we are doing the union operation. Okay. So if leader of both the members is not the same, we will unite them. Okay. And we are uniting them with the help of union by rank. So if the rank of first leader, like the leader of member 1, is less than the rank of leader of member 2, we will simply mark the leader of member 1 as the leader of member 2. Okay. And we will increment the rank of leader of member 2 by the rank of leader of member 1. And what would be our answer? Since like suppose we have to unite here, we will have to unite these two, and let's say it contains only 3. This particular leader has only 3 members and this particular leader has 4 members, and we are uniting these two members. So like and these are connected, let's say. So what will happen here? The rank of this leader would be increased. Why? Because I am firstly checking now, like the rank of leader of member 2. If it is greater, so I am adding the value of lower one. So now the rank of this leader will become equal to 7. Okay. And now this leader is itself the member of this leader. So this is what we are doing in this union member function, and simply we will return the answer. In the answer we are storing the rank after the union operation. Okay, and then we will update our answer as the max of answer and the result of union members function. This is what we have done for upper cell, and I will do the same thing for the left cell as well, for the left adjacent cell. If the left adjacent cell is valid, and if its value is equal to 1, I will do the same thing that like which I have done for the in this case. Okay, and at the last we will simply return the answer. Let's discuss about the time and space complexity. Like the time complexity is going to be the same as the DFS approach, big of and cross M, and the space complexity is also going to be the same. Why this is so? Because union and rank operation, like for finding parent and union operation, as you can see here we are using path compression. So like we are finding leader with the help of path compression method. Okay, and we are doing union members with the help of rank. So the time complexity of doing this operation union members will become amortized constant, like it would be equal to constant. We can assume it to be constant. Okay, amortized constant. So we are doing nothing, we are going traversing, like firstly we are traversing all the rows, like I am iterating rows one by one, and for each row I am traversing all the cells in that particular row. Okay, so it is going to be big O of n cross m, and the space complexity is big O of n cross m. Why n cross m? Because I have used leader vector, okay, of size n cross m, and I have used rank vector of the same size n cross m. Okay, and here n denotes the number of rows and m denotes the number of columns in the given vector grid. Okay, let's discuss this edge case. Why I'm updating answer as 1 initially. Like if the grid value is 1 initially, so we will update answer as 1. Why? If I have not done this one, like I have not updated answer as 1, so we would have got the wrong answer for this case. Like this is my grid. Okay, so to handle such cases, we have used this particular edge case. To handle such edge cases, we have updated answer as 1. Okay, so that's all about today's video. Thank you everyone.